Hi, I'm Ben Gromicko from InterNACHI. We are going to learn in the next few minutes about heat movement. And heat, energy, moisture, insulation, they're all related to each other. Now, I'm in the heat movement section of the free online course provided by InterNACHI to members, and the course title is How to Inspect the Attic, Insulation, Ventilation, and Interior course. And in the heat section, we're going to learn about these three methods, how heat transfers by radiation, convection, and conduction. So get your hot cup of coffee and let's learn a little bit about these topics. Now, as inspectors, we should understand how heat moves around inside a home and how insulation can control that movement. One important reason we need to understand how heat moves is because warm air can carry moisture, and warm, moist air needs to be controlled in relation to the building envelope. Now, I've seen this before in a home inspection. This is a picture of a defect in the wood floor caused by moisture. Uncontrolled, moving warm air and moisture can cause a lot of problems like that. Another reason to learn about heat is that insulation provides resistance to the flow of heat, and the more insulation there is, the less energy is needed to heat and cool a house. Heat needs to be controlled in order to keep the home occupants comfortable, of course. And when a home is well insulated, your client will also save on heating and cooling costs. After learning the information provided in the next section here about heat, moisture, air, insulation, you'll be able to perform an inspection armed with the knowledge of what's needed to gain greater energy efficiency and speak authoritatively to your clients about how well the building envelope is functioning toward that goal. Now, let's talk about heat. There's essentially three ways that heat moves from one area to another. When bodies of unequal temperatures are near each other, heat leaves one body and goes to the other. Heat moves from the hotter body, and the colder body absorbs it. The greater the difference in temperature, the greater the rate of flow of heat. So heat moves, again, from one body to another in the following three ways: radiation, conduction, and convection. So let's learn a little bit about radiation. Radiation is the transfer of heat energy by electromagnetic wave motion. Heat is transferred in direct rays, in a straight line. It travels in a straight line from the source of the heat to a body. The closer you are to the object, the warmer you feel. The intensity of the heat radiated from the hot object decreases as your distance from the object increases. You'll feel cool in a room that has a cold floor, walls, and ceiling. The amount of heat loss from your body in that room depends on the relative temperature of the objects in that room. So the colder the floor is relative to the temperature of your feet, the greater the heat loss from your body will be as you continue to stand there. If the floor, walls, and ceilings of that room are relatively warmer than your body, then heat will be radiated to your body from those warm objects or surfaces. When you step into a cold room, you can immediately feel the heat energy leaving your body. Use all of your senses as an inspector when moving about the house. Just entering a space with your body can give you some clues about the insulation, the heat, air movement, and even moisture and humidity levels. Some inspectors can provide a good estimate of the temperature of a really hot attic space simply by entering it. Keep aware of your surroundings while moving about the interior of a house. Radiant heat emits in all directions. Radiant heating in residential homes includes the piping and electrical wiring in the floors, walls, and ceilings. Reflective materials are commonly used in radiant heat emitting systems in order to direct or control where heat is emitted. Radiation happens when heat moves as energy waves, called infrared waves, directly from its source to something else, and this is how the heat from the sun gets to the earth. In fact, all hot things radiate heat to cooler things. When the heat waves hit the cooler thing, they make the molecules of the cooler object speed up, wiggle around, move. When the molecules of that object speed up, the object becomes warmer. Let's talk about conduction. Conduction is the transfer of heat from one molecule to another, or through one substance to another. It is heat that moves from one body to another by direct contact. For example, heat is transferred by conduction from a boiler heat exchanger to the water passing through the boiler heat exchanger. When an air conditioner unit is operating properly, the liquid line should feel warm to the touch and the suction line should feel cold. Heat is a form of energy, and when that heat comes in direct contact with matter, it makes the atoms and molecules move. When the atoms and molecules move, they collide with other atoms and molecules, making them move too. And this movement transfers heat from one thing to another through matter. It's demonstrated when touching a ceramic cup with your hand. The exterior surface of the cup is warm to the touch because the heat of the coffee was transferred through the cup's material. Convection. Now, convection is commonly understood by many people through the phrase warm air rises or heat rises. Convection is the transfer of heat by warming the air next to a hot surface and then moving that warm air. It's the transfer of heat by the motion of the heated matter itself. The air moves from one place to another, carrying heat along with it. Since warm air is lighter than cool air around it, the warm air, or heat, rises. Warm fluids tend to rise while the surrounding cool fluids fall. This rising and falling motion tends to form loops or convective loops where warm air rises and the cool air falls. Early, old, warm air furnaces, gravity furnaces, operate by the principles of convective loops. In a gravity system, the warm air rises and the cool air falls in a house, and this is how the gravity warm air heating system circulates the air in those old homes. When a certain amount of air is heated up, it expands and actually takes up more space. In other words, hot air is less dense than cold air. Any substance that is less dense than the fluid, the gas or liquid, of its surroundings will float. Hot air floats on cold air because it is less dense, just as a piece of wood floats because it is less dense than water. Warm air is often described as weighing less than cool air. Warm air rises and cool air falls. The weight per unit volume of air decreases as its temperature increases. And conversely, the weight per unit volume of air increases as its temperature decreases. Now, inside a wall cavity, there can be convective loops where cool and warm air are moving around inside the wall cavity. If warm, moist air comes in contact with a cold surface of that wall assembly, then condensation may form inside the wall, and we all know as home inspectors that's not good. Another example, an old gravity furnace heats up the air. The air gets lighter and rises out of the heating system. Cool air enters the heating system and pushes or displaces the warm rising air. The warm air rises up through warm air ducts or pipes, often called stacks, that are inside the walls. The warm air rises up through the building. The warm air enters a room through the supply registers on the wall or floor, and then the cool air falls out of the room and may return through a return grill or travel back through return ducts to the heating system. Some houses with old gravity heating systems may not have a lot of ducts at all and may rely on large openings in the floors covered with beautiful iron grates or grills that allow that cool air to fall down through the building, through the floors, into the basement where the heating system is. The cool air is allowed to simply fall back to the furnace, hence the name, gravity warm air heating systems. Air circulation in a house with a gravity warm air heating system depends on the temperature differences between the warm air rising and the cool air falling. The greater the temperature difference, the greater the speed of the air circulating. So, in summary, heat moves from one body to the other by the following three ways: radiation, conduction, and convection. Understanding how heat moves will help us, as home inspectors, understand how moisture moves too. And that's the next section of the course. I'll see you there.